My name is Neil Douglas, and here's my journey in math and science. Now, early in my life, math and science were my favorite subjects. Back then, math was easy for me. Addition, subtraction, multiplication, long division, fractions, you name it. I was good at it all. I was confident and sure of my abilities. In the primary and junior grade levels, I excelled. I often received rewards from my teachers, and I was excited to show my good grades to my parents. I couldn't wait to get to secondary school and try more advanced experiment. However, I quickly noticed that I was in for a reality check. The comfort that I experienced in my junior school was replaced by a sense of nervousness, confusion, and a sense of being just a number. The assessment process changed as well. Instead of being in a familiar room, I was herded into large exam rooms with other students and forced to write exams designed to deceive, discourage, and fail students. Oh, how I felt lost in those days. Though my marks remained high, my stress, sleep patterns, and life suffered greatly. More importantly, I lost my enthusiasm for math and science. Why did this happen to me? Well, Stiegler and Hibbert write, cultural activities are represented in cultural scripts, generalized knowledge about the events that reside in the heads of participants. These scripts not only guide behavior, they also tell participants what to expect. So in the case for my math and science classes, the method I was taught changed, my script changed. The process was less about experimentation, trial, and problem solving. It became a transmission of textbook information. The whole idea that kids are these empty vessels that need to be filled with information upon entry into the classroom. Like, what the heck happened? I don't want to do math or science. I went from an active learner environment to a stale doctor's office environment, waiting for my bad results day in and day out. I was determined. to figure out a better way to teach. I wanted to teach math and science the way I knew it could be taught, a way I'd learned when I was a kid in grade school, with the joy of math and science. So first I had to figure out what was different. The only way I knew, I had to start to try and understand the issue I had and the issue that I would have moved forward. Carpenter and Lair write, they speak to the development of understanding not only as the linking of new ideas to existing ones, but as development of richer and more integrative knowledge structures. These structures allow students to use the new ideas they learn rather than only to be able to repeat what they have learned. Ross, Hagelbaum, Gray, and McDougall in 2002 wrote, classrooms with rich tasks embedded in real-life experience of the children and with rich discourse about mathematical ideas and success to be measured on both traditional math tasks and problem solvings. I know I'll adapt a constructivist approach, the one written by Carpenter and Lair in 1999. But what does that mean? Well, unlike a more traditional approach in which teachers focus on the transmission of mathematical content, in a constructivist classroom, students are recognized as the ones who are actively creating their own knowledge. From Cobb, 1988, who explains that the two goals of the constructivist approach to mathematics are students' opportunity to develop richer and deeper cognitive structures related to mathematical ideas, and student development of a level of mathematical autonomy. So I think I got it. I will use a constructivist approach and create an active learning environment. And in conjunction, these two principles will provide a deeper and richer learning experience for all my future students. More importantly, an active math and science classroom is not just a lot of me walking around and talking, although this may occur, but rather on problem solving and reasoning in the evaluation of evidence in mathematical situations. I want my students to not only know what 3 times 5 equals 15, but I also want them to know what it represents, like 3 equal groups of 5, 5 plus 5 plus 5, the area of a rectangle with the dimensions 3 by 5, the result when a rate of 5 is applied 3 times, like traveling 5 kilometers per hour for 3 hours equals 15 kilometers. That is real understanding. And that is understanding that can be easily used in conjunction with manipulatives, like dominoes, blocks, or other practical items to enhance the student's knowledge and understanding. So, no more walking around, talking, and giving tests.
Created using Powtoon.